Welcome to this latest video. We're going to be looking at object-oriented programming. We're going to be looking at how to declare a class, how to establish its attributes, its methods, how we will declare an object, so how we instantiate an object from that class. We will then look at looking at the concepts of encapsulation by data hiding. We will have a look at inheritance, how to make use of constructors, and finally polymorphism. So there's a lot to get through today. We're going to use as an example students, the idea of a generic student, and then the idea of a subclass from that student of a child, of a post-16 student. Anyway, so I'll get started. We're going to start with making a new project. We'll go for applications, and the one we'll go for is we'll just go for, I'm literally going to call it student. Finish, and here we're at. We've got our place we've been before, which is just this empty class. But what I want to do, which is different from before, is I want to create different types of students. In fact, do you know what? I probably shouldn't have called this original class student. That was a boo-boo, but we'll go with it for the moment. So we'll call secondary student. So if I go with my project, I've got my one class here called student. I'm going to right click on here. I'm going to say new Java class, and the new Java class is, I'm going to call it secondary student. Okay, and it's going to belong inside here, inside the if you see in here in the project, it's going to belong here as another class. So far my secondary student is pretty empty, not much going on in here. So let's give it some properties, some attributes. So let's give it two obvious ones. Let's say there's the name, so string name. Remember, the class is a blueprint or template. It doesn't have state, so I'm not going to give it one right now. And I'll say int age. So currently it's got two attributes, name and age. Now I'm going to go back to my original student here, my original student class, and I'm going to make use of this secondary student in here. So remember before you could do something like string name equals Bob, something like that, and you declare the data type, then the identifier, then the value. Now we're going to do something similar. Our data type is the class. So the class is secondary student. Then we need to give it a name, and of course I'm going to call it Bob. Of course I am. And then we're going to go equals, and then we're going to go new secondary student. Open and close bracket, because currently I'm not sending any values, but I do need to instantiate it. And then colon. So Bob exists. Now, what is the name of Bob? Well, Bob right now is the identifier of the class, but it's actually not its name. So I'm going to say Bob. Then we've got these two attributes here, name, or let me make that bigger because that is not possible to see. There we go. We've got name and age. So I'm going to say Bob, which is my object, dot, and when I go dot, it will show all the things that are inside that class, which is currently just two things. So I can go dot name equals, and I'll set it to Bob. So I've instantiated an object of secondary student, call it Bob. So Bob's my object, and then Bob is a individual object that I can give it some values, some properties. Remember I used the analogy of like a cookie cutter. So secondary students like my cookie cutter, I went and I've cut out an object, I've instantiated an object called Bob. If I want to set the age of Bob, I can go Bob dot age equals, I don't know, 14. If I want to create another object, I can go secondary student again. I can call it stu1 equals new secondary student. What is the name of stu1 object? It has no name, and so again I could go stu1 dot, allows me to access all the things associated with it, name equals, I don't know, Axel. It's Guns N' Roses time. If you don't know what Guns N' Roses are, you missed out. and then you can give it an age. So what's happened here is I've used my secondary storage cookie cutter, got out, instantiated a new object. So this is a separate object from Bob called Stu1, and then it's got its own age and name. You can make as many of these as you want, and you can just keep instantiating. Okay, now I said we talk about encapsulation, polymorphism, inheritance, and constructors. So the first thing I'm going to do is encapsulation. So the idea of encapsulation in object orientation is that the attributes and methods are all wrapped inside this class. So all the functionality exists inside this class. And one of the things you need to do is something called data hiding. So instead of name and age being directly accessible from one class to another, it should only be accessible inside that class. So in here, I'm going to set these attributes to private. So I just write the words private at the start for both of them. And now both these attributes are private and only visible throughout the scope of this class. So check this out. Suddenly it's gone to red squiggly lines under .name. Well, how come? Well, from its point of view, from this class's point of view, when I go bob.name, because I'm seeing it from another class, it goes, there is no such thing as name. Name is literally hidden, like it never existed. If I delete the if I delete this private again, and I go back to my original class, you see? Now it's visible, it can be used. So the idea is you're not ever supposed to directly access the attributes. They should only be accessible through its methods. So to do that, underneath, let's do the method. So there are called setters and getters. So for name, I'm going to have set name. In fact, no, I'll do the getter first. Get name. Now, if I'm just returning the name, I don't need to send it a parameter, and I'll say return name. Now, in here, one of the things I'll need to do is say if I'm getting a name, what data type's being returned. What data type's being returned? A string. I should also say whether it's private or public. Now, I want it to be visible in other classes, so I'm going to call it public. If I want to set the name, I also want to do public. I'm not returning any value, so I'll say void set name. If I'm setting the name, I'm going to need to receive a name as a parameter. So string n, and then I'll say name equals n. In here, if I want to set the name for Bob, I can't do it like this anymore. I can't say bob.name. I'll do Bob, because that's the name of my object, dot, and you see now I've got set name and get name. So dot set name, and I can send it Bob. Later on, if I wanted to print it out, I could go system.println, and I could say Bob dot get name. Let's get rid of these ones here, and let's just keep us to Bob, and let's see what's going to happen if we run this. So what's happened? Oh, I don't need that line there either, actually. So I've instantiated a new object called Bob. I set, because I can't access it directly anymore, the attribute name, I access and change the name via its method. So I do bob.setName and send the value Bob. And then when I print out the get name from it, it will return the string, and then it will say the name Bob. Okay. What do you think you need to do with age? It's set to private, so you're going to need to create a getter and setter for it. So here's what I would do. I'd pause the video now and see if you can write the getter and setter for age. So give it a pause, and when you unpause, if you're stuck, I'll show you how to do it. Okay, so the getter and setter, in fact, it's just public, because again, you want it visible in other classes. Whoops. It's going to return a int this time. Get age. I don't need to send it a value, and then just return age. And then for setting, public again. I'm not returning something, I'm setting it, so void So it's a procedure, set age. I am going to have to send it the value I want to change, so I'm going to call it int a, and then age equals a. In here, I can go Bob dot, and now you see I've got set age and set name. So set age, and we'll say it's 14, and we can say Bob dot get name plus, and we can concatenate is plus, and I want to get the name back. So what's the name of the object? The object's called Bob dot, I want to get the age, get age. So if I run this now, Bob is 14. So what we've done is we've made the attributes only accessible through the getters and setters. The way you access those things is by going dots, and you get all those properties. Okay, so this works. It's got a downside. The downside is like, doesn't this seem like a pain? That you have to create the object, you have to instantiate the object called Bob, and then later on use its setters to change all the values. Oh, actually, let me do one more thing. I was going to do a constructor, but before I do that, think about set age. Now, what you might want to do is a bit of validation, because maybe you want to make sure it's sensible. So you could say if a, so the age you've been sent, is going to be greater or equal to 0, otherwise that doesn't make any sense, right? And a is less than 100. So what I'm saying now is that unless the age is greater or equal to 0 or less than 100, well, actually that's a bit unfair, because if you're over 100, this don't work. I suppose it's for students, to be fair. Now I'm going to catch it, and if it's not going to do anything. Maybe I should have an error message, but let's not overcomplicate things. And you can see why then it would be better not to directly access age, because now I can catch simple mistakes. Okay, let's do this. The next thing I want to work on is, instead of creating this object, let's see if I can make this a bit bigger. Instead of just creating Bob and then setting the values, I want to instantiate Bob and set it the values at the same time. How do you do that? Well, you do that by creating a constructor. How do you do a constructor? Here's how you do it. You say public, because of course it has to be visible to the other class that's creating it or instantiating it. You call the constructor by the same name of the class. So I have to call it SecondaryStudent. Witness how I didn't put void or the data type, because I'm not returning anything in a constructor. What values is it going to receive? Well, it's going to receive a name, and it's going to receive the age. And then I'll say name equals n and age equals a. So how does the constructor work? You write it like a subroutine. You don't give it a data type to return, even don't need to do void. You give it the same name as the class. You make it public, so it's visible, because obviously when you create it, it needs to be public. You say what data it's going to receive, and then initialize it with those things here. Now I could, of course, just initialize age as being 10 every time, but that would mean every object I have literally be started with 10 as its age. Let's go back over here, see what's happened. Now you see that's gone not happy with us now, because it's expecting us to send it the values. So now I'm going to send it Bob and 14. And the set age will still work, but you see now I both instantiated the object and used the constructor to set values on creation. Let's do another one. So I'm going to create another student. So I'm going to do my stu1, and when I create it, I'll set the value to Axel and to 17. And then I can just create new objects every single time like this. Just for you to notice, when we use the scanner class from before, if you see how it works, scanner was just a class like you've done over here. It's just a written class, and in its constructor you send it where the value is going to come in. So you've been doing this the whole time already, but maybe without noticing. Okay, so what have we done so far? We've done how to define a class here, how to do its attributes, how to set them private and only access them through getters and setters. So that's called data hiding, and does the concept of encapsulation, of wrapping the attributes and methods inside a single entity or class. We've shown how to instantiate a class. Here is an object. How we set the values using Constructor. What's next? Why don't we do inheritance? So we've got our generic secondary student class. Why don't I have a post-16 class that gets to inherit all these attributes and methods, but also maybe we have an additional attribute, maybe like UCAS application, true or false. So I'll go into my projects. I'm going to right-click on my student folder, new Java class. I'm going to call this post-16 student and finish. And I want this class to inherit all of the attributes and methods from secondary student. How do I do that? We see where it says public class p16 student. You then write extends secondary student. Oh, it's going to blow up for a second because allow me to do something first of all. I need to just get rid of this constructor because it's not going to be happy. Right, so the constructor's gone. Where are we? There we go. So I had to get rid of the constructor. I will fix that in a moment, but let's cross one bridge at a time. If I go back to my main student class, oh yeah, that's not going to be happy with me because I'm using constructor. Let's show this post-16 student in action. So p16 student. So p16 1 or p16 student stu1, post-16 student 1 equals new p16 student. Okay, well, how has that worked? Because in here, I've put nothing. I've just said extend secondary student. Well, remember with inheritance, you inherit every attribute and every method from the parent class, from the superclass. So you see here, that's inherited all that stuff. So in fact, it's inherited the methods get name and set name. So in here, I could say for p16 stu1, I could say dot set name. I don't know, Jordan. You know. Extend secondary student. Let's try that again. p16 student 1 stu1 dot. It's not extending. 1 second, people. I've clearly done something stupid, so my bad. Secondary student. Have I mistyped it? No. Private. Pieces. I've extended it, but it's not working for me for some unknown reason, which I can't quite figure out why. It should work, but should and does are two slightly different things. p16 student, p16 stu1 extends secondary student.
Does p16 student its own constructor?
No, but I've removed the constructor. Constructors aren't actually necessary. You know what? I might try and fix the constructor thing and see what happens. Let me fix the constructor, and maybe that'll get us somewhere. I don't think it actually has anything to do with that. There's some other weird problem. But anyway, so I've got this constructor here, secondary student. It won't inherit it directly, so I have to create a new one. So public piece. Oh, weird. It shouldn't make any difference, but whatever. I have a new attribute here, private string. No, actually, private boolean UCAS, and that will literally keep track of whether they're applying through UCAS or not. So I've got one new attribute, public p16 student. I'll have to receive all the parameters I sent the other one. So if I believe that's string and int a, and let's say boolean u, and I can say super n a. So what did super do? Well, the relationship between post16 student and this is that this is the superclass secondary student. When I said super, it took n and a and sent it directly to this constructor here. Now that's not totally finished, because what I also want to do is set a new one here, which is UCAS equals u. Okay, well, hopefully this will not blow up less horribly in my face. Let's see what happens. Post16 student is new post16. Okay, so let's give it a name. So it was Jordan, and it was I don't know, 17, and then true. Okay, now it's working for me. God knows. Oh, and we can put these back into play because I put the constructor back there. Okay, so and let's see then if the class works full stop. Yeah, get age, set name. Who knows? Who knows? Maybe it hadn't initialized because I had literally written nothing there. So I could set the name now to something else if I wanted to, like, I don't know, glob. Brilliant, okay? Because now, if you remember with the way inheritance is going to work, post16 student is going to inherit all the attributes from secondary student, so it's going to inherit name and age, but it will also declare this new one called UCAS. We should make a getter and setter for, set UCAS and get UCAS. All right. So what we've done? We've done classes, we've done objects, we've done constructors, we've done instantiating objects, we've used data hiding, so we've done encapsulation. Now we've done inheritance. Polymorphism. So this is the last of our hits. So this is the last one we need to hit. Let's create a new method. So not a getter or a setter. Let's create a new method in here. Public boolean. Oh, actually, public void age valid. Okay. This is just going to check to see if the age isn't the valid thing. So if age is greater than or equal to 11, and age is less than or equal to 18, then that's a valid age. So we could say this out. This age is valid, and maybe we'll just append the age to it. And if it's not the case, then we'll say something like this age is invalid. Now, at the moment, we got Bob. We set him to this. Can we apply to given types? Where are we? At the moment, this age valid is not going to work perfectly for both of them because age valid for secondary student is 11 to 18. So I'm going to copy that code here for secondary student and post it in here. But now we're going to need to change that. Super dot get age. So the reason we can't access age is because it's in the superclass and we said it's private. So I'm going to access the superclass by typing in super dot get age. So that was the accessor, and if it's less than it. And we'll have to do the same here. So we'll have to go in here and say that these are super.getAge. This is super.getAge. This age is valid, and we could say, but this time, because it's post 16, we'd say it's between 16 and 18. Where were we? Back in here. Right. So currently, we want to run the code. So we're going to say we've got Bob, Stu. So we say Bob dot. What was the name of the function we just wrote? Age valid. And if we run it, it should say Bob is 14. Bob is 14, which is and this one here, and we say the age is valid 14 because for a secondary student it's between 14 and 15. But if I said, for instance, let's make Bob a post 16 student now. So I'm going to copy this. I'm going to put it in here. I'm going to delete our old Bob. Goodbye, Bob. And we're going to say that P6 student we'll actually call him Bob. His name was Bob, but his age was 14. The idea is that we've got the same function, age valid, and we can actually make use of it in slightly different ways in two different contexts. I don't know.
Too many Bobs.
Yes, the age is invalid, 14, because now I'm calling the age valid from this one, the post 16 version, and because 14 is not between 16 and 18, it says the age is invalid. While if I say for post 16 student 1, so I can say P16 student 1 and say age valid, because I've set the age to 17 for this one, it should then say the age is valid for 17. My suggestion would be, why don't you make another class, maybe a different type of student class you could call Key Stage 3 student, and then you could have a go, so it should inherit from secondary students, so you make a new class, Key Stage 3 student, extends secondary student, and then you'll need to, maybe we'll add in something different for Key Stage 3. I'm trying to think of a new property. Maybe it could be something like, I don't know, house you belong to or something. And then you could go Harry Potter, you could do Gryffindor or whatever, your choice. And then, but this time when it says age valid, you clearly want to tweak it so it's between 11 and 14 to then tweak the properties that way. And then maybe have to do Key Stage 4 student between the ages of 10 and 11, and you can maybe about destination